Okay, hello everybody. Hello, hello. Thanks to the magic of tutors who, no, cool, yes. Tutors who know what they're doing, we have a document camera and a projector this week. Okay, he just plugged in the HDMI cable. Whatever, so, cool. All right, hello, how's your week been, or your 5 days? I'm seeing some nods, thumbs up from the thumbs up guy at the front, that's good. How did you find your shoots and labs last week? Pretty good? Pretty horrible? No, mostly good? Cool, so today we're gonna review some stuff from last week a little bit, and then talk about an absolutely fantastic thing called functions and abstractions, so it's gonna be great. So some quick admin stuff before we get started. First of all, don't panic. I said that last week and the week before. I'll say it again this week. Programming is hard. Learning a new skill for anything is hard. It takes regular practice, and if you've been going to your shoots and going to your labs and doing the activities, then you're completely on track. Those of you who are new programmers, raise your hand if you hadn't programmed before this course. How are you finding programming now? I got an okay from someone? Cool. Hopefully it's starting to feel a bit more comfortable and a bit more natural and a bit less sort of, I don't know what's going on. But even if you're still feeling kind of, I have no idea what's going on, it's cool. We'll get there. We can do it. I believe in you. Cool. So next thing, you might have noticed that we have these milestone write-ups as one of the assessment tasks. The details, I sent out a quick announcement saying, don't stress, I'll tell you what they are soon, and a little bit about them. I'll talk about them, maybe I'll talk about them now. I've got some slides on them. And another thing, assignment 0 is coming out this week. In computing, we count from 0, so that's like the first assignment, but it's called assignment 0. So I'll go over that as well, I think, in the second half of this lecture. So let's talk about milestones for a bit. Roughly every 2 weeks, you're going to have some short questions for you to kind of give brief responses to. So the goal is that it's a quick and easy thing for you to do, and it just helps you think about how you're going in the course and helps you keep on track. So one of the themes will be looking at your overall progress in the course, and so kind of measuring where you're up to, seeing what you've done well, seeing what you can improve on, setting some goals, trying to, make yourselves better. And the other one is looking at what I and others refer to as craftsmanship, which I don't think I have a slide on. Cool, so looking at craftsmanship, which is, I was reading the Google definition of craftsmanship, and that was really good. So I'll Google that again now. Or maybe I won't. Is everybody on the internet again? Are you guys all using up the internet? You are, aren't you? Come on. But this one has a plug. So Google defines craftsmanship as a skill in a particular craft. I admire his engineering skills in craftsmanship, or as the quality of design and the work shown in something that's been made by hand. And I think this fits in really well with programming, because programming, it's a craft that we can develop skills in. You can become a skilled programmer. You can, build programs. And programs are something made by hand. I think that sums up programming really well, because even though we make them on a computer and we run them on a computer, you as a programmer, you as a human are the one creating the program. And I think, like I've talked about a lot so far in the course, I think programming is more than just writing code that works, but it's writing code that's, quality of design, writing code that's, good code. And so that's sort of the second theme of these milestones. So you'll be doing something like looking at a piece of code you've written, or talking about one of the labs you've done, or something like that. Cool. Is that like microphone feedback? Oh well, and so there is a milestone page on WebCMS which maybe doesn't appear yet. I can probably get to it under here, maybe. Cool, so I'll make this public probably during the break so that you all can see it, but I've got a page describing what they are, just describing pretty much what I've said, saying when the first one is, saying hey or submit, and some resources for extra support. Hopefully with the milestones, they'll help you kind of keep on track during the course. So how many of you have found, either in university or school or life, you kind of fall behind in things, like you do your best to keep up and things get hard and you kind of struggle to do assignments sometime or you start them late? I'm seeing very few hands. Okay, I feel like maybe there's more than have raised their hands. I personally find this really hard as well. You can have the best intentions. You can think, oh, I'm going to start it early this time, going to get my assignment done, going to get everything done, it's going to be great. And it's really easy to fall behind and get stressed and kind of lose track of how you're going. And so I'm hoping the milestones will help you keep up to date, or at least keep track of how you're going. And if you're finding that things are really hard and you're struggling, there's all sorts of extra support you can have. So you can do kind of more check-ins yourself, or there's some resources at UNSW, there's some people you can see, or there's some self-help things. So this will be on the website, I'll put it up during the break. But lots of extra support there. If you're finding uni hard, which I think we all do, how many of you find uni really easy and you've never found anything hard? You've never struggled with anything? I saw one jokingly raised hand. Yeah, so there's lots of support out there. Cool, and then the questions that you'll be answering for this week's milestone, I'll put up as well, probably tonight. Cool, there we go. So it's due, we'd say it's due at midnight on Sunday, but does midnight on Sunday mean midnight when Sunday starts, like just after Saturday, or does midnight on Sunday mean just before Monday starts? And because that's a really hard question, like in computer science, in life, right? You say that and people are like, which of those does it mean? So in computing, we specify very exactly, Sunday midnight, I specifically mean 11:59 p.m. on Sunday. So 1 second before it becomes Monday. And instructions on how to submit and everything will be up. Cool. So you'll be creating the milestones on your blog. You will have a blog on this course. Some of you have even written blogs already, which is really cool. And some of your activities this week will be submitted via your blog as well. And just to show you how cool they are, so when you're on the course website, if you scroll down to the bottom, this little speech mark bubble, and click on that, you have a blog where you can post about anything you want to post about. So I made one last night. Make another blog post. Hello from the Monday lecture. Monday lectures are great. So one of the things you can set in here is who it's viewable by. The default is course, which means anybody in the course can see it. So I reckon that's good. You can set things to only me, which is private. You can set them to public, or you can set them to course staff, which means tutors and lecturers. So one of the things you might want to post blog posts about are activities you've done and code you've written. This is really good. You might find it helpful to write about your code or whatever, but make sure you set it to course staff so that only course staff can see things like lab exercise code and that sort of thing. So blogging about it, yes, great, but make sure it's course stuff. But I'll make mine be course so that everybody can read it. There's also a blog stream that might just be the word stream on the end. Maybe? Yeah. And so I'll put a link to this in the sidebar, but you can see all the blogs from people in the course. So you can see I've posted one here, hello from the Monday lecture. Roy's posted a thing saying I found the blog. Curtis posted one last night. Tess post, please ignore. I posted one last night as well. Anyway, it's very cool. You can see other people's thoughts and progress and stuff. I think it's really cool. Makes me happy. So, yes, more on blogs soon. But let's just review the stuff from last week a bit. So thinking about number systems. So we can represent the same numbers in many different ways. And the document projector works this week, which is awesome. Document camera. Okay, so I think it's on there now. Maybe. Yeah, okay. So if I draw some numbers here, and then I hit that focus button. Is that going to work? Yeah. So if we think about the number 28, is there a way that we can make the number 28 from these numbers I've got written down here? So we can use each number either once or no times, but not more than once. And I want to make the number 28. So how do I make 28 from this? Any ideas? Yeah? 16 plus 8 plus 4? Is that what you said? Cool, let's give that a shot. So if we have 1 16, that's 16 so far. 1 8, 16 plus 8 is 24, I thought so. Just testing you guys. Plus 1 lot of 4. I don't know if you can see that. Oh, you can. Cool. Gives 28, and then no lots of 2 and no lots of 1. Cool, good work. Do you think we can represent any number in this way? Like, do you reckon we can make any number just from these, the 1, the 2, the 4, the 8, the 16? No? Very good. What if I then extended 16 to have another number afterward? Yep, very good. What's your name, by the way? Adam. You always sit at the front and give me thumbs up, and I forget to ask your name. Maybe I've asked your name before and I forgot. I'm sorry. So Adam said, with these numbers, we can't make anything bigger than 16 plus 8 plus 4 plus 2 plus 1. But if we extended it infinitely, so if we added on another number after this and after this and after this, then we would be able to have any number. Any number? Kind of negative numbers. What about non-integers, like, 3.1, 1.5? Yeah, well, you guys and your hard questions. But we can represent any whole number like this, any positive whole number, any integer. Okay, so if this is equivalent to 28, how could we convert this to hexadecimal, to base 16? Do you guys remember what we said last week about hexadecimal? Try writing it here. So we have like 0 is 0, 1 is 1, 2 is 2, all the way through. 9 is 9. Has it gone off the page? Nope. But then 10, instead of being 10, becomes the letter A. 11 is B, 12 is C. I'm going to run out of space. Go. They just fit. Yeah, 15 equals F. And so hexadecimal numbers were just another way of representing numbers. So we can describe a number in another different way, but have it be the same number. So in this case, if I have, reminding you of the hexadecimal numbers here, how would we make 28 from the hexadecimal numbers? It's a much harder question. Let me show you a really cool way of doing it. So the way that I like to do it, like we could do the same thing here. We could have 1s and 16s and 256s and then go through and count how many we have. But if we have the number in binary, we can do like a magic trick. We draw a line for the first 4 digits going from the small end. Then we draw a line after the next 4 digits, and so on. And then we take this group of 4 digits and turn that into one letter. So if I have the number 0011, that's no lots of 1, no lots of 2, 1 lot of 4, 1 lot of 8. What number does this give us? C? Yes, it gives us 12 in decimal, C in hexadecimal. So I'm going to write C down there, 12 in brackets. And if we take this number, we've got a 1, a 0, 0, 0. What does this give us? Yeah, 1. If we look at this, ignoring the 16 and just taking this as like an individual group of things, we have one lot of 1 and no lots of anything else. So we have 1. And so we've converted this hexadecimal number, sorry, this binary number that we made from 28 into the hexadecimal number 1C. Much easier, in my opinion, than going through and counting how many 16s and so on. And just to show that it's hex, the convention is we have 0, x, and then the number, so 1C. Cool. Does that make sense? Sort of, kind of, hopefully. Cool. And so we'll have more, actually, I think we have more on this right now. Back to the projector. Yeah. Cool. And so that's just showing what I showed. The 28 in base 10 or in decimal, like in normal numbers, is the same number as 000111100 in base 2 or in binary. And that's the same number as 0x1c or hexadecimal number 1c in base 16. So we've got some more exercises we can do. And I thought I'd gotten rid of those ones, so ignore the ones with 8s on them. So if we wanted to convert the number 53 into binary, that will require the document camera again. Actually, why don't you guys do this? So with the person next to you, grab out some pen and paper or write on your computer. Don't do a program to do it, but do the like numbers by hand. Try converting these numbers. So converting 53 into binary, converting this hexadecimal number into binary, and then convert these ones into hexadecimal. Okay, how are you all going? Have you managed to convert the numbers? Cool, yep, thumbs up. So, a brief interjection, I've put the lecture slides for today's lecture up on the course website. Didn't quite make it before the lecture, but I did make it during the lecture. So they should be up and visible to you guys now, if you want to follow along on those. Cool, so looking at these numbers we have, converting these to binary, converting 53 to binary. So how did we do that? Yeah, divide by 2 a lot of times and take the remainders. That works. Let me... Okay, so what did you get for that? Is there a 32 in 53? Yep, so we've got 32. Do we add a 16 to get to 53? Yes, no? I'm seeing a yes and a no from people next to each other. 16? Cool, so a 16, a 32, no 8s, 1, 4, plus 1, 1 gives us 53, which you can just see there. Cool. Conveniently, I have the answers on the next slide. I just have to ignore these 8s again. So, what did we have there? 1, 1, 0, 1, 0, 1. Cool. Converting 5F3A to hexadecimal. Did you pick up on the cool way of doing it where you can take just the digit 5 and make 5 in binary? So 4, no lots of 2, just 1 makes 5. Making F in binary 15 is 1, 1, 1, 1. Making 3 is 1, 1, and 1, 2. And then making A, which is 12, 11, 10, which is 10, is 8 and 2. Cool. Okay, and so the answers for these are in the slides as well if you want to check on those. But let's move on to something else. Let's move on to something completely different from numbers, insofar as anything is completely different from numbers. So, hey, okay, so if you think back to the code you've written so far in this course, or so far in your life, have you ever had to copy and paste a bit of code and kind of do the exact same thing over and over again several times? How many of you have had to do that? Yeah, quite a few of you. For any of the stuff this semester, have you had to do that so far? Any of the lab activities or? The word adder and the challenge question, aren't they the same thing? Right, the number words in the word adder, yep. Yes, any other examples from the stuff so far this semester? Those were the ones that came to mind for me. How many of you tried the word adder challenge exercise last week? Cool. How many of you didn't try it because you looked at it and you went, this is ridiculous, I'd have to copy and paste the same thing over and over again so many times, it's not really worth trying? One person, fair enough, a couple of people. So wouldn't it be nice if we had some way we could avoid having to copy and paste blocks of our code? Like we could get around the need to go, oh, I want to do this thing and then do it again and again and again, so I would, not have to copy and paste it. What if we could make parts of our code be reusable? What if we could make our programs, make our main function be smaller and simpler? So, your program, you have your int main, you write the code in there. What if instead of that being complicated, that could just be a couple of lines and that's the whole program? Magic, I know. And what if we could make our programs be nicer to read? Introducing functions. So functions are a really awesome thing in programming. They're really cool, and they let us do all of the aforementioned things. So first of all, what are functions? I'm pretty sure you've all seen them outside of programming. Have you seen inside maths you can do like a sine and a cosine? Yeah? Has anyone never heard of a sine or a cosine before? Okay, some of you. So in maths, like you take an angle, I don't actually really understand them myself, it's been a long time since I did high school maths, but like you can take an angle and you can apply a sine or a cosine to it and then you get a number out. That was really badly explained. What about a more abstract example? You could think of a toaster as being a function. And why would I say a toaster is a function? Because I'm crazy, yeah, maybe. Okay, think of a toaster. You put something in, you put the bread in, and then it gives you toast out. So it's this magical black box, or kitchen appliance, where you give it some sort of input, for example, a piece of bread, and then the function does its thing, and then you get some sort of output, so in this case, a piece of toast. And that's just exactly what functions are. They're like a black box where you give it some sort of input, and it'll take, bread, for example, and a toaster, or numbers in the case of like a sine or a cosine. It does some magic inside that you can't see, and then it gives you some sort of output out. I think toasters are a good example because you can't really see the magic of the toast being made, unless it's a toaster that's see-through or something. So there are some key things about functions. One of them is that if you give it the same output, if you give it the same input, you'll always get the same output. So thinking of a toaster, for example, in our nice hypothetical world where, the things I'm saying actually apply to reality, every time you give a toaster bread, it'll give you back toast. So it's not like one time you'll put bread in and you'll suddenly get, I don't know, a slice of cake out. We know that with the toaster, every time we give it bread, we'll get toast out. And functions in any sense, in the mathematical sense, in the programming sense, are like that. If we give it the same input, we'll always get the same output. And you've also already seen functions inside programming. So when we do something like printf or scanf, those are examples of functions that we've used. And we talk about the main function in your program, the int main. That's a function in itself too. And functions are cool things because they're a way that we can achieve abstraction. And abstraction is one of the kind of fundamental things in programming. One definition of it is saying that with abstraction, we're creating units which can be reused and whose internal details are hidden from outside inspection. And so I think that describes the toaster pretty well. We have our toaster, we can reuse it, we can make more and more toast. But the way that it actually works is hidden from outside inspection. And so we could buy a new toaster, right? A completely different toaster that might work in a different way. It might have like a little nuclear reactor inside or something like that. But as long as it still makes toast, we'd still view it as a toaster. And so functions in programming allow us to achieve abstraction. We can separate out or encapsulate, as we'd call it, a piece of code that serves a single purpose. So by this, I mean, if we have a piece of our, if we're doing something in our program that we do over and over again, we can sort of take one chunk of it that does one thing, and then have that be our function. Encapsulation is, yeah, I'll try again in a minute. So we can separate out a piece of code that does a single thing. We can test and verify a piece of code. So thinking about the programs you've written so far, and for those of you who have done programming before, thinking about the programs you've written, how many of you have written a program that was completely correct and didn't have any bugs in it and just did everything completely perfectly? Raise your hand if anyone's ever written a program that was completely correct. One person, up the back. How do you know? How do you know it was completely correct? Say that again. Sorry, say that again. The auto tests tell you it's correct. Very good. But are the auto tests correct? What if there's a mistake in the auto tester code? What if there's, what if we haven't tested a certain case? So what about if we made it, so if we're trying to test your whole program, we can have, if you think of the number word 1, so that was, you scan in the number like 1, for example, and you print out the word 1. You scan in the number 5, print out the word 5. You scan in the number 10, you print out that's more than 5. That sort of program is fairly easy to test, hypothetically, presumably. Like, we can give it all of the possible inputs. Well, we can give it the numbers 1, 2, 3, 4, 5. We could give it like a negative number. We can give it like the number 10. We can sort of cover the possible cases, the possible things our program will do. But imagine if our program was more complicated than that. If it did all sorts of different things all in one go. Trying to test that that works is quite hard. Well, it's very hard, really. Especially because everything kind of has a flow-on effect. So maybe we've got a mistake in how we scan in the number for our program. Maybe we scan in the number wrong. And then when we try and print out the number as a word or something like that, we don't know whether that part of our code's wrong or whether a different part's wrong, whether the input's wrong. And the great thing with functions, if we can separate out our code to the little blobs that do just one thing, it's a lot easier to test that this little one piece of code does this one thing. It's a lot easier to test that that will do it correctly. So, for example, if we had a program that printed out hello, all it did was print out hello and nothing else. How do we know if that program's correct? Anyone? Yeah, we run it and it prints out hello. And if that's all our program can do, if it doesn't have any input or if it doesn't have anything else like that, we can sort of assume that it's correct if it does it, and every time we run it and it does the same thing, it prints out hello. So another thing with functions is we can reuse a piece of code. So to those of you who did the Word, what was it called, addition Word Edition, I think, the calculator. So that was an extension from last week's lab exercise of scanning in, for example, 2 and 5 and printing in 2 plus 5 equals 7, doing that with words. So I know when I wrote that, when I wrote my answer to that, I was kind of feeling quite uncomfortable the whole time because I had to copy and paste these massive chunks of code. So my program was like 200 lines long, and it was sort of the same thing copied and pasted 3 times, and I was just, it's quite unpleasant. So when we use functions, we could reuse a piece of code. Rather than copying the same thing 3 times, or maybe more times in a different sort of program, I can just write it once, and then I can reuse that piece of code over and over again to do different things. Another advantage is we can shorten our program, so we can make our programs be shorter overall. And a shorter program isn't necessarily good. We could write the code for our program, for some problems that we're solving, we could write the code for it in a very, very short way by kind of shoving all of the if statements on one line, for example. Actually, that's a great example. Let me go to that one. So one of the things you may or may not have seen under lectures, I've been putting up the lecture code. So you can go to that and you can get this, and I think lessons.c. So let me zoom this in so it's readable. So these are the various codes that the tutors wrote, and one of them, oh, it's wrapped around, that's disappointing. Let me open that in Notepad. Ah, there we go, cool. So I'll get one that's easy to view on one screen. Apologies for the lack of syntax highlighting. So we could have this one, for example. If the speed's more than the speed limit, you're arrested. Otherwise, if you've got this license and this speed, you're arrested. Else if this, so on, else. So this is fairly easy to read, more so when it's syntax highlighted in a nicer font. But you can look at this and you can go, oh, okay, I know what's going on. It's this, or it's this, or it's this. Another way that we could write that is having it all in one line. So if the speed's greater than the speed limit, or your license is that and that, or that and that, and that, and that, or that, and that, and that, and scrolling all the way across. This program is shorter. This program is fewer lines. If I did it this way, there's like 1, 2, 3, 4, 5 lines rather than 4, 5, 6, 7, 8, 9, 10, 11, rather than like 12. So look, it's less than half as long. It's clearly a better program. But I would say that's not actually a better program. That's actually a lot harder to read. So a shorter program, shorter doesn't always mean good, but shorter can be better if we're removing duplication, if we're removing like copied and pasted blocks of code, if we can only have it in one place rather than in several places. It's easier to change what's going on, and it's easier to fix bugs. Imagine if you're done. Let's go back to the Word Edition one. Imagine if you'd done that lab exercise, the challenge one from last week, where you had to copy and paste the code over and over again. Imagine if you had a mistake in your block of code that you copied over and over again. You'd have to go through and fix the mistake in every place where you'd copied it to. And that can get a bit painful when you've copied it multiple times, which is another reason why functions are great. So how are you guys feeling? Do you feel like a break now, or do you feel like a break in 10 minutes? This is a good place to stop, but otherwise I can go for 10 minutes and then we can stop. Let's break? Okay. So we'll have a quick break. I will actually cut you off after 15 minutes this time, so if you ask me unlimited questions, I will send you away at some point. But otherwise, get up, stretch your legs, grab a drink, whatever you want to do. Be back here at 1:05.